Welcome students. The class today is on lung compliance. What do you understand by the term compliance? At the end of the session, the student should be able to define compliance, list factors that increase and decrease compliance, and list the components and functions of surfactant. So, compliance is used to reflect lung distensibility, the ease with which an object can be deformed. How easily you can deform an object or how easily an object yields to your deformation is called as compliance. Elastance is opposite of compliance. That is, it reflects the opposition of an object to deformation. It refers to the recoil tendency of a structure coming back to the original position. The thoracic cage has a tendency to move out and the lung has a tendency to move in. So, the thoracic cage always has a tendency to expand, whereas the lung has a tendency to collapse. What is lung compliance? A change in the lung volume for each unit change in transpulmonary pressure. What is this transpulmonary pressure? The transpulmonary pressure is the difference between the intra-alveolar pressure and the intrapleural pressure. The intrapleural pressure is a negative pressure. The intra-alveolar pressure, we call the intra-alveolar pressure as 0, -1 and +1. We use 0, -1 and +1 as reference point for the intra-alveolar pressure. It is 0 means it is equal to that of the atmospheric pressure, -1 means it is less than the atmospheric pressure, +1 means the intra-alveolar pressure is more than the atmospheric pressure. So, lung compliance is how easy the lung can be stretched. So, transpulmonary pressure, which is the difference in pressure between the alveolar and the intrapleural pressures. Compliance is measured by measuring the intrapleural pressure at different lung volumes. We measure compliance both during inspiration and expiration. So, in the x-axis you have the pleural pressure ranging from -4 to -6. In the y-axis you have the lung volume. It is 0.25 or 250 ml to 500 ml. This is the normal volume. 500 ml is your what you call as the tidal volume. The amount of air that is breathed in and breathed out during normal quiet respiration. So, as the pleural pressure, the intrapleural pressure becomes more negative, what happens when it is becoming more negative? The parietal pleura moves out along with the thoracic cage. How this movement of thoracic cage is achieved? Because of contraction of the inspiratory muscle. The inspiratory muscle will cause movement of the thoracic cage and the sternum and the diaphragm. Okay. The thoracic cage is going to move. The parietal pleura is moving out. It is going to create a negative pressure. The increase in the intrapleural pressure is going to occur, which will move the visceral pleura, causing expansion of the lung. This lung expansion will cause fall in the intraalveolar pressure, which is going to suck the air in. So, here as the intrapleural pressure becomes more negative, you can see the lung volume is increasing. The increase in lung volume with change in intrapleural pressure is not the same during inspiration and expiration. The curve we draw with the intrapleural pressure and lung volume in x and y axis respectively is different when we record during inspiration and expiration. So, this is called as hysteresis loop. This is the inspiratory compliance curve. This is the expiratory compliance curve, and midway between these two is the normal or the average compliance. The types of lung compliance, you have static and dynamic lung compliance. The static lung compliance is when measured in lung where there is no active airflow. To measure the static lung compliance, we force little volume of air at a given time and we measure the volume and pressure. Then after some time again you increase the volume, measure the pressure. So pressure and lung volume is measured when there is no active airflow. In dynamic lung compliance, we measure the pressure and volume when air flows in and out of the lung. When the lung is active, we are measuring the lung compliance. So what is this curve? Here, as the intrapleural pressure is becoming more negative, the lung is expanding, causing movement of air, causing the inspiratory curve. How this is measured? You take a deep inspiration to total lung capacity, then you try to expire out periodically. You stop the expiration, measure the pressure change and the volume change. Again you allow the person to expire a little, then you measure the pressure change and the volume change. With periodical interruption, you measure the lung volume and pressure. So as the person is expiring, so you will get the expiratory curve. From functional residual capacity to total lung capacity, when the person is inspiring, you get the inspiratory curve. From total lung capacity, as the person is expiring out, you get the deflation or the expiratory curve. So when a person inspires from FRC, functional residual capacity, to total lung capacity, you get the inspiratory curve. And when the person expires from total lung capacity to FRC, you get the expiratory curve.